Hey everyone, Scott from Octava Engineering here, and today we have brought the RunWELL Plus out to play, so we can do a final test run on the Siemens 1PH spindle motor here. So if you're not already aware, with the RunWELL Plus, it can handle the larger servos, 25 to 50 amps, and you also have the ability to run smaller to mid-size spindle motors. And actually do final testing on them. So let's take a look at what that looks like. I'm going to go to Motor and Final Test. So plug my Ethernet cable into the RunWELL Plus so it connects to the drive. There we go. Now we're connected. And this particular motor is running an incremental Heidenhain HTL encoder, a ROD 420. And then the number of pole pairs, obviously for a spindle motor, don't actually matter, so I just threw in 4 pole pairs there. Under motor parameters, we are going to select spindle. And this current rating for this motor is 34 amps. Rated speed is 8,000 RPMs with no brake. And then again, as I always say for the final test module, the runtime should actually be long enough to get the motor warm and up to operating temperature. So a motor this size, I would actually run it for at least an hour. But in this case, I'm going to leave the runtime at 1 minute because it is just for demonstration purposes. And then the grayed out analytics time here are the number of test minutes that are going to be used for the final test for the analytics process. So 12 test minutes. And then for the speed, I'm actually going to keep it a little lower because I'm standing right next to it. And I just don't want to inadvertently injure myself. So once you have that configured, we'll go ahead and click Clear Faults. Enable access. And we will begin the test. So the first thing that's happening was that the encoder had to index. So this angle dial won't start moving accurately until the encoder is indexed. You can see now it is, and that's part of the calibration procedure, verifying that we see movement from the encoder as we instruct the drive to actually rotate the motor. All right, now that the calibration procedure is complete, we actually we actually skip the commutation check because a spindle motor is asynchronous. It does not have a lock-in angle, so there is no lock-in angle or degree to check to make sure that the alignment is good. So we have skipped straight to getting amperage, or we simulate a load test on the stator and measure the current draw from each of the phases. All right, and now that that's done, we are going to reprogram the drive so that we can perform our first round of analytics. So now we're measuring and analyzing all the signals from the encoder, one channel at a time, and we're doing it simultaneously while that spindle motor is in operation. And if you have an oscilloscope hooked up to the Linea as well, you can view those signals in real time on the oscilloscope as they're being analyzed. And also as a reminder, as we go through the analytics process here, Just want to point out that the RunWELL Plus, unlike the regular RunWELL, the smaller RunWELL, the Plus runs on 480 volts AC, and it does have to be wired for 3-phase. All right, so we should be finishing up our first analytics phase now. There we go. So now we're going to move into the free run period, which again, normally for a motor this size, I would set at about an hour. But for this demonstration, we're just going to do 1 minute. And that is to get the motor and the encoder up to operating temperature, as I said, and listen for bearing noise, feel for any kind of abnormal vibration, things like that. Because this is a spindle motor, it should spin very smoothly at higher speeds. All right, so that's our elapsed free run time. All right, and after the second calibration procedure, again, because there's no alignment to check, we're going to skip the alignment part and move straight on to our final analytics phase. So once again, we're checking all the encoder signals and analyzing them, except this time now, presumably, the encoder is hot under a certain amount of heat stress, more like it would be in an actual operating environment. All right, and we are towards the end of that second 6-minute block for Analytics 2, so the test should be nearing completion now. And there we go. There's our worksheet pop-up for the report. So fill out your customer name, job ID. We perform the test. Encoder and motor ID, as you may have heard me mention in other videos, we always recommend using the serial number of the device as opposed to the model number. Or both. And then once your worksheet is filled out completely, then you click Save and Show. And there is your final run report for this Siemens Spindle Motor. So encoder's in excellent shape, almost 100%. Couple of variance noise blips there, but nothing serious. And there's our stator graph from the simulated load test. So yeah, there we go.